This is an overview of the types of non-electrical sensors for online PD detection. The first of these sensors is sound-based. It is sound in the ultrasonic frequency range, which is beyond the capability of the human ear to hear. The detection of ultrasound means that there are piak sound within the assets that you are measuring. The second of these sensors is infrared thermal scan. There may be localized hotspots which the naked eye cannot see. Such defects will be easily detected by infrared thermal scan. The third of these sensors is dissolved gas analysis of transformer oil. This is analogous to taking a sample of blood from the human body and doing an analysis of the contents of the blood to infer problems with the heart, liver, kidney, etc. In the same manner, a sample of oil is extracted from an energized transformer, and by measuring the amount of dissolved combustible gas in the oil, you are able to determine the condition of the transformer. The fourth of these sensors is analysis of SF6 gas inside a GIS. The SF6 gas inside a GIS is like the blood of the human body. By chemical analysis of the SF6 gas for purity, water content, and presence of decomposition products, you are able to determine the condition of the GIS. The fifth of these sensors is airborne particle detection. If the measurement equipment indicates the presence of large quantity of airborne particles, it is indication that something is slowly burning away. The last of these sensors is video image based, analogous to a doctor putting a video probe into your large intestines to see problems. We use a video scope to see behind a protective panel of cable box in AIS and transformers. These non-electrical PD sensors are logical enhancements of our basic senses to detect problems by hearing, seeing, and smelling. This part of the sharing talks about the use of electrical sensors to detect PD. I will be sharing my experience in using electrical sensors for online PD detection. This includes measuring PD in 3 frequency range: 3 to 30 MHz HF or high frequency range, 30 to 300 MHz VHF or very high frequency range, 300 to 3000 MHz UHF or ultra high frequency range. These 3 frequency range will have different types of electrical sensors for PD measurements. This includes TEV or transient earth voltage, HF current transformers, VHF current transformers, UHF current transformers, antennas, and capacitors. These electrical sensors are specifically designed for PD detection. There are other sensors which are designed to measure other parameters, but because of its embedded nature within the electrical assets, can also act as PD sensors. I will share 2 such types of sensors. The first is the RTD embedded inside the stator windings of motors and used for temperature measurements. RTD stands for Resistance Temperature Detector. The second is the VDS embedded inside a GIS to detect the presence or absence of voltage at the cable termination. VDS stands for Voltage Detection System. It is sound wave that is beyond the hearing range of the human ear. The human ear can hear sound in the range of 20 to 5,000 Hz. Ultrasound traveling through air is about 40 kHz and beyond the frequency range of the human ear. Ultrasound traveling through denser medium like oil and SF6 has higher frequency. The front end of any ultrasonic measuring equipment is a quartz sensor, which converts the ultrasound into electricity. This phenomenon is called piezoelectric effect. The voltage developed by the quartz sensor will be very small and has to be amplified. The output of the amplifier is still in the ultrasonic frequency, which the human ear cannot hear. This electrical signal has to be frequency shifted to the frequency range of the human ear. Ultrasonic measurement requires a direct line of sight to the source of the ultrasound, and so unable to measure if there is a protective panel to the electrical assets. Infrared thermography or infrared thermal scan can detect localized hot spots which the naked eye is unable to detect. The hot spot is detected by heat sensing. It is the temperature difference that is more reliable indicator of localized hot spots. Infrared thermal scan requires line of sight to the source of the high temperature for measurement, and so will not work if there is a protective panel to the electrical assets. This slide is about dissolved gas analysis of transformer oil. The transformer oil is like the blood of the human body. In a medical checkup, a sample of blood is taken and sent to a lab for analysis. The results can indicate problems with your heart, liver, kidney, etc. Similarly, by analyzing the transformer oil for presence of combustible gas dissolved in the oil, you can detect problems at the transformer. The oil sample can be taken from the transformer without any need to de-energize. The traditional method is to send the oil to a lab and wait many days for the results. It is now possible to do on-site DGA and have the results within the same day of measurement. It is like getting the doctor, nurse, and measurement set come to your house for a blood test and get immediately results for the blood test. This slide shows the list of gases that are measured in DGA. There are 9 gases, of which 6 are flammable. These gases are hydrogen, methane, ethane, ethylene, acetylene, carbon dioxide, carbon monoxide, oxygen, and nitrogen. The presence of hydrogen will indicate PD. The presence of acetylene will indicate arcing fault. The presence of methane, ethane, and ethylene will indicate thermal faults. The presence of carbon dioxide and carbon monoxide will indicate problems at the paper insulation. Large variation in oxygen and nitrogen will indicate contact of the oil with the outside air. This slide is about the use of chemical analysis of the SF6 gas to detect problems in GIS. The SF6 is analogous to the blood in the human body. Problems inside the GIS can be detected by chemical analysis of 3 parameters. The first is the purity of the SF6 gas. The second is the amount of water in the SF6 gas. The third is the amount of decomposition product in the SF6 gas, example SO2 or sulfur dioxide. This slide is about the use of airborne particle measurements to detect problems inside a AIS, cable box of transformers, and LV switchboards. Localized hotspots will burn off insulation and will release particles into the surrounding air. These airborne particles will be small and not visible to the naked eye. Time to failure will be soon if large quantity of airborne particles are detected. Such detectors are usually the same detectors used for smoke detections in public buildings. Example of a common brand is VESDA, Very Early Smoke Detection Apparatus. I have a picture showing one of my engineers using a portable unit for airborne particle measurements. This slide is about the use of video scope to see defects that are hidden from view because of a protective panel. There may be termite trails or rainwater ingress which will be reviewed with the use of video scope. The picture shows my engineers looking behind and into the metal enclosure of a dry type transformer. The other engineer is looking inside the cable box of an outdoor oil transformer.